So right off the bat, we have some simplification: 3 times 7, 5 times 2, and 3 times 10. And these all fall within the multiplication facts, which we would really like you to memorize. But if you didn't memorize them, you could even go back to changing these to addition, right? You could say, for example, 3 times 7 is 3 groups of 7 that are being added, by the way. So it's like saying, yeah, 7 plus 7 plus 7. However you do this, you're going to end up with an answer of 21. Now, again, if it's easier for you to think about that as 7 groups of 3, that works as well. And yeah, since this is a review, I am kind of not going into too much detail on this stuff. We do expect you to have at least some background knowledge on this, right? Which you should. So the next one, yeah, again, you could write this as repeated addition. Not that you have to, but that would be 5 2's being added together, or 2 5's. And yes, that one would have been more convenient to just put in 2 5's. Either way, all right? Your answer, one way or the other, is going to be 10. Or this next one, it's 3 groups of 10. So you could write this as 10 plus 10 plus 10. This one's not too bad. Like, even if you stacked it, 10 plus 10 plus 10, like with this addition, well, 0 plus 0 plus 0 is 0. 1 plus 1 is 2. Plus the third one is 3, so that'd be 30. And yeah, we've seen that with when you multiply with values that end with zeros, like the 10 here. That means we could have just done 3 times 1, which is 3, and then tacked on the 0 from the 10 on the answer. So 3 different products, and yeah, it's shown 3 different ways, right? With parentheses and multiplication and x multiplication, and then I'd say that's the dot multiplication, either way. All right, simplify with division, no problem. Well, and yeah, for these ones, you could, if you wanted to, use the fact families for that, right? Like the 15, that's the dividend in the division problem, which means it's also the product between 3 and whatever this equals. And once we know what something times 3 is equals 15, that something is the value we're looking for. And if you knew that's 5, that's one way to say, okay, I know the answer to this one is 5. But if you took 15 and split it up into 3 different groups, you'd still get the same answer on that one. And yeah, it is possible to show this with a diagram. Not that I'm big on diagrams, but 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Well, look at this. If you split this up into groups, there's 1, 2, 3 groups. How big is each group? It's 5. And yeah, the diagrams like this, they're fun, and they can be catchy, but once you get into some bigger values, it becomes a little impractical to use. So this next one, I'm going to write this with just division, which would be 10 divided by 2. I mean, the fraction line is division as well, but I think right now we're trying to get used to seeing this division sign still. And yeah, if you prefer to see this as 10 divided by 2, so be it, right? It's the same thing either way, so 2, we'd say maybe it doesn't go into 1, but it will go into 10, 5 equal times. And so 5 times 2 is 10. So this shows a remainder of 0, and yeah, our final quotient here is just 5. So what about this one on the bottom? Let's see, I'll use orange. Well, 11, again, that's one of those, we do expect you to have all the multiples of 11 down all the way up to 55, right? Because 55, as it turns out, is the 5th multiple of 11. Yeah, 5 times 11, that's exactly 55 right there. So when we subtract that out, it would show 0 remaining. So our final quotient, or just simplified, it's just 5. All right, so 3 times 7, and also 3 times 4. A couple 3's on this one. We're looking for products on this. And yeah, it's not saying that we have to use any specific method, it looks like. Just need to simplify. So we're solving 3 times 7, 3 groups of 7. Yeah, what the heck? Still 21 on that. Or 3 groups of 4, right? Again, even if you change this into addition, well, 4 plus 4 is 8, and then plus this other 4 here. 8 plus 4, that'd be 12. 8, and then, right, you could say you're using your fingers, and then 4 more fingers gives you that 12 right there. Either way you do it is good. Now, again, I did show that with addition, but it would, as far as I know, it wouldn't be required that you show the addition when you make these calculations. It may want you to change, or just to show that you understand that multiplication is repeated addition, and I think we see some examples like that in this review. Yeah, some more division. These ones, 6 divided by 2. No matter how you do it, this is kind of the most common way we've seen it, right? With long division, 2 will go into 6 exactly 3 times. 3 times 2, 6. So when we take that away, we've distributed all the 6, and we just get that quotient of 3. 10 divided by 4. This one is nice because 4 will not go into 10 equally. So what does that mean? It means we should have a remainder, some amount left over after this. 4 will go into 10 twice. Right? If I said 3 times, it's just too many. 3 times 4 is 12. So when we take that away from the 10, it means that we distributed 2 too many, because you'd end up with a negative value there. Not that we've gone over negatives yet, but we shouldn't see negatives right now. So 2 times 4, though, is 8, which is enough to take away from the 10. 10 minus 8 is 2. So that shows a remainder, right? Which means that our quotient is 2, and our remainder is also 2. Yeah, here we go. Expand this. Now, expanded form means that since this is multiplication, we're looking for repeated addition. And yeah, there's 2 different answers that would work on this one. Let's look at both. So for me, I would say this is 5 groups of 7. So that means I would have 7 5s. And since it's multiplication, did I say 7 5s? I meant 5 7s. There's 5 7s right there. And since it is multiplication, it's repeated addition. So that's one way to put this out. But you could have done 7 groups of 5, right? So it's be 1, 2, 3, 4, 5, 6, 7 5s. And yeah, these are all being added together. So either one of these would work, even if you were taking the quiz. So write this given repeated operation in condensed form. Okay. Well, on this one, I'd say, hey, what number is being multiplied, or I'm sorry, added over and over? 1, 2, 3, 4, 5, 6, 7. What number is being added over and over? It's 3. Okay, so that's one of the factors automatically. Next up, we just got to put how many 3's there are, and we just counted those. I actually forgot what I counted, but I recounted in my head. 7 right there. 7 3's. So 3 times 7 would work, or if you wanted to say, and this is probably what I would have done, 7 groups of 3 like this, that works as well. So either one of these should give you full credit on the quiz. All right, we see some bigger multiplication in this case, even though the first two, 11 and 12, again, they're part of the multiplication facts that we would like you to memorize. But we can't stack these, right? If you wanted to, you could say, well, 11 times 8. And yes, I did change the order there, just because for most students, it seems like you prefer to see the smaller of the two numbers as the bottom when we stack these. But again, if you put it in the top, that's fine. So for this, I'd say we'd start with the ones place value. 8 times the 1 in the ones place value. 1 times 8 is 8. Nothing to carry there, so I would multiply the 8 by the tens place value. Another 1. 8 times 1 is 8. So our final product on this is, well, 88. And we'll do the same thing with 9 times 12. I'll do this on the left, give myself some space. This is 12 times 9, or 9 times 12. Again, the order of these doesn't matter because of the commutative property of multiplication, so you can switch them around if you choose. And yeah, I would say 9 times the 2 in the ones place value, 9 times 2 is 18. And yeah, we do have to carry in this case. And then I take the 9 times the 1 in the tens place value, which is 90, or 9 really. And then I do have to add that 1 that carried over. So 9 plus 1 is 10. That's 10 tens, which makes 100. And yeah, our final product on this one is 108. Now this next example, 30 and 700 are very large numbers. especially when we're looking at multiplying these. I definitely would not want to use repeated addition in order to figure this out. If I can just multiply these. And yeah, we got the two numbers. We got a 0 from the 30 and then two zeros from the 700. And what this means is, since we're multiplying, I can just tack on those three zeros on the answer. So I know my final answer should have three zeros tacked onto it. It's just, what am I actually multiplying? It's the 3 and 7. So I would say, well, 3 times 7, that is 21. Oh, I did that backwards. So the final product on this, after we've tacked on those three zeros, right, is 21,000. And we'll do the same thing with 80 times 50. So there's a 0, there's a 0. That's two zeros. 1, 2 zeros. And then all we're focusing on is the non-zero numbers, 8 and 5. 8 times 5. Again, if you need to count by fives, like you should have your fives down, hopefully by now. 5, 10, 15, 20, 25, 30, 35, 40. That would be the eighth multiple of 5. Or maybe you just knew that, and that'd be fine. And we got 40. We tack on the other two zeros from the 80 and 50. And this final product is 4,000. All right, here we go. Some non-zero multiplication on this. I know there's the 0 and the tens place value, but we can't just take it out and then apply it to the product, right? So we're going to have to stack these up. It's good. I like the multiplication with stacking. 7,304. Yeah, we do have that 0 in the tens place value multiplied by 2. And yes, I did reverse the order, which is okay because we are dealing with multiplication on this. So that's the commutative property. So I'm going to start with the 2 and the 4 in the ones place value, right? 2 times 4, that's 8. Nothing to carry over there right there. That's fine. That's good. Now I go from 2 into the tens place value. So that'd be two groups of nothing. So that would leave me with no tens at all, 0 tens. And yeah, we do need the 0 to hold that tens place value in the product. So then I go into the hundreds place value. That's two groups of 300, which would be 6 of those hundreds. So we get a 6 in the hundreds place value. Nothing to carry still. It's kind of surprising at this point, but that's okay. I assume we'll see some eventually. Now 2 into the thousands place value. 2 times 7,000 would be 14 of those thousands. No need to carry in this case. 2 times 7 is 14 because we don't have to multiply the 2 by any of the 10,000s place value. So our final answer here, 14,608. And don't let the parentheses confuse you. Remember, if you don't see an operation, multiplication is the only operation we don't have to show in certain scenarios, and this would be one of them. So while it does not show an operation, that should have tipped us off right away that is multiplication. Yeah, more multiplication. Let's go ahead and stack these. So again, I'm going to put the bigger of the two numbers on top, 343, and we're going to multiply this by 31. This one could get quite colorful. We'll see. So again, I start with the 1 in the ones place value, 1 times 3. And by the way, yeah, this means, like, if you were to expand these, which you're welcome to do, but for the most part, students seem to prefer this in, I guess, shorthand method. You could start with the 3 in the tens place value and then multiply the ones through the place values as well. And then remember, we're just really adding those two products together, right? So starting with the 1 and the 3s, I'm not gonna start with the 3 in the tens place value though. So 1 times 3 is 3. That would give me 3 1s. And then 1 times 4 tens, that would be 4 tens. That's 40. So I put a 4 in that tens place value. And then 1 times the 3 in the hundreds place value, that's one set of 300. That's just 300 right there. So multiplying by 1 is nice, right? That's the identity property of multiplication. And so, yeah, if you knew that, maybe some of this is a little obsolete to you, but if you're struggling with this, I do hope that it does help. So now I go to the 3 in the tens place value, right, from the 31. And I say, okay, since we're in the tens place value, you can't possibly have any 1s. So I'm going to start with tens. Whatever this first product is between the 3 tens from the 31 and the 3 ones from the 343, that product is going to tell me how many tens this would produce. And 3 times 3 is 9. So nothing to carry over now in what will be the hundreds place value. But that's now in 3 times 4, which is 12. This one will require some carrying now. So I'm going to put that 1 above the 3 there in purple. And now I've got 3 times 3, which is going to give us the thousands place value. That's 9. But when I add this 1 here that carried over from the 4 times 3, I actually get 10. And yeah, again, I didn't need to carry the 1 from the 10 over because there was nothing else to multiply. So we just need to add these two products, and that will tell us our final product of 343 and 31. So 3 plus 0 is 3. 4 plus 9, 4, 1, 2, 3, 4, 5, 6, 7, 8, 9 is 13. Carry the 1. Now we got 1 plus 3 is 4. 4 plus the purple 2 there is 6. And yeah, the 0 and 1 are going to drop. So we didn't see a lot of carrying on that. That's okay. Yeah, if you prefer to put the comma in there, feel free to do it. Shouldn't matter. But our final product is 10,633. All right, estimate using front-end rounding. Remember, when we use front-end rounding, we're going to do the rounding first, and then we'll use the multiplication, all right? And yes, if you multiply these at first, it could throw your answer off, actually quite badly sometimes. So it is important to know that we do need to do the rounding first. So 7,643. I'm going to show the stacking of this, though, even though I'm not going to use this first stack. 7,643 times 2,379. And yeah, I know you could figure out, everyone, I think, could figure this one out, but rounding this is going to make this a lot easier, okay? Let's go and round these two, starting with 7,643. So I would look at the front number, 7,000, and since that's the place value I'm rounding to for front-end rounding, I would look immediately to the place value to its right. Now this is the hundreds, and that 6 is 5 or more, which means I need to take the 7 and add 1 to that. 7 plus 1 is 8, and then these other 3 place values to its right become 0. So that now becomes 8,000. And then I would look at the 2,379. The 2 in the thousands place value is in the front end there. So immediately to its right is the 3 in the hundreds place value. So the 3, it's less than 5, which means the 2 in the thousands place value is just going to stay at 2. So now that becomes 2,000. Now this would be a really nice problem if it was addition, but it's not. It's not addition. It's multiplication. So what I'm going to do then is I'm going to just count the zeros and tack that onto the answer, and that would leave only the 8 and 2 to multiply, right? So how many zeros is the final product going to have here after the front end rounding, of course? Yeah, 6 of them. 1, 2, 3. That can represent the 3 green ones, and yeah, the 3 purple ones there, another 3, 6. And then all we got to do is 8 times 2. Well, 8 times 2 is 16, and it looks like our final product here then, 16 million. Now we see the convenience of front-end rounding. And now these ones I'm not going to stack. We'll just kind of show the multiplication, but let's round these just as is. So I would say, look at the front-end rounding both, by the way. So we got the 2 in the hundreds place value from the 273. Immediately to its right is a 7, which is 5 or more. So I do need to add 1 to the 200 place value, which would make this then 300. And then we need to round the 2,983. Okay, there's a 2 now in the thousands place value. The 9 in the hundreds place value is 5 or more, which means just like we did with the 273, we need to add 1 to the 2 in the thousands place value. So this becomes 3,000 now. And just like I've said before, it doesn't matter that the two numbers were rounded to different place values, because front-end rounding doesn't really care how many place values a number has. We're always looking at the front end no matter how big that value is. So since this is a product, a multiplication problem, again, we're just going to count the zeros. 1, 2, 3, 4, 5. We know that the final product will then have 5 zeros on it. So there's 5 zeros. And then all we got to do is multiply the two non-zero numbers, which is 3 and 3. So 3 times 3 is 9. So putting that onto the answer with the 5 zeros there makes that 900,000. All right, writing numbers. This is an exponential form, right? We got an exponent and a base. But we're going to write this with its repeated operation. And we should remember from this, from the section that we went over this stuff, what was that, 2.4, I think. The base here is the 7, and the 5 is the exponent. The base is the number that's being multiplied over and over. And yeah, that's our repeated operation in this case, is multiplication. And the exponent tells us that it's repeated multiplication. But this also tells us how many 7s are being multiplied by themselves. So I'm going to take the base of 7. I'm going to create 5 of them. 1, 2, 3, 4, 5. And yeah, it's just multiplication between each of these. Now, I think we did a problem already where it was 7 times 5 or something like that. Remember, this one's different. It's a different operation that we're looking at repeating in this case. And the other difference is when we did 7 times 5, you may have been able to do 5 plus 5 plus 5 plus 5, 7 of those 5s, right? But this is not reversible with exponents like this. It can only be written in this form if we write it with its repeated operation. All right, so let's do the reverse of that then. So this is repeated multiplication, which means that we're dealing with a base and an exponent. So what number is being multiplied over and over and over here? 3. So 3, 3, 3 is being multiplied over and over. So it's a base 3. And then just, well, how many 3's are there that are being multiplied? That will be the exponent. Again, it's just a smaller number that you can put in the upper right corner of whatever your base is. How many 3's is that? 1, 2, 3, 4, 5, 6 3's. So this would be 3 to the power of 6. And that's how that reads, 3 to the power of 6. And we rewrote it. Later on, we'll be solving for those, but for this problem, we just wanted to write it in its condensed form, which is, I think that's pretty convenient. All right, simplify 5 to the power of 2. No problem. We can do that. Now, whether you know this or not, like you have this exponent memorized, you can, if you'd like, to write this as repeated multiplication. Hopefully this would help one way or the other. So 5 times 5 we know already is, well, 25. That's it. Or this one. This would read the square root of 121. Now remember, it has to do with squares. So if I looked at a square, let's pretend like I drew a square right there. I mean, even if I clean this up, it's still kind of poor, but this would be like saying the area of the square is, well, 121. Now, area is found by length times width, but the unique thing about squares is that those two values are the same, right? So it's really side length times side length. And yeah, we do know the area of this one. That's what the square root gives us, the 121. So really, we should be asking ourselves, just like we talked about in this section, what number multiplied by itself is 121? And that number is 11. The number multiplied by itself is to make 121 is 11. So the square root of 121 is 11. Bam. All right, use the commutative property, rewrite the given statement. If not possible, we'll write NA. That's okay. And yeah, it's not asking us to solve this, which again makes this, I think it's pretty convenient. The commutative property. Well, the commutative property just says that these two values, we're just going to switch, right? The order of them. So the 14, I would say that would be the front factor. And then the 23 can just be the second factor, that's all. So that's 14 times 23. And yeah, it would be equivalent. And that would demonstrate the commutative property. That's what we want right there. Now this next one, 20 divided by 4. This is division, and yeah, we cannot use the commutative property with division. So yeah, this is an NA, maybe a DNE kind of thing. So yeah, this is now the associative property. Of course, we just finished the commutative, now associative. And remember, the associative property won't change the order of these values, right? And yeah, if it's not possible, we'll put NA. But let's just look at this first one. So we got three different factors, 36, 5, and 9. And really, I am ignoring that parentheses right there because I need to know that the associative property won't change the order of these factors. So even though we're going to show the property, the numbers, the factors, need to be in the same order, 36, 5, and 9. The only difference, yeah, for the associative property is to move the parentheses. So where it started around the 5 and 9 factors, I'm going to move it so that it's around the 36 and 5 factor. That's all on that stuff. And yeah, just like we saw with the commutative property of multiplication, when we see division, we cannot use the associative property. So this is another NA scenario. Or you may see this as a DNA. It may ask you to type in DNA on the quiz. Right, finding the missing number using the identity property. I like the identity property because it's the identity, right? Here's 12. That's an identity. Well, if you multiply it by 1, you get the same identity back, 12. Or down here, where we've multiplied by 1 to get a value, I would put its identity multiplied by 1. Boom, there we go. And yeah, just like we talked about in this section, eventually we're going to make these phantom ones, which really is what this has done. And this may come as kind of alarming, but there is a multiply by 1 right there. It's just we don't usually show it. And that's kind of what the identity property is telling us. So those phantom ones are there. They're always there, watching, which is what makes them so creepy. All right, find the missing number using the inverse property. Well, in order to find these blanks, especially this first one, we see it's 19 divided by 19. Right? Anything divided by itself is 1. And yeah, you could say, well, couldn't you just use the identity property? Yeah, if you change this into a multiplication problem with its fact family, so the dividend here is 19, so it had to be the product of the two factors. Well, the one factor there is 19, and the other one, again, since we have the identity, one identity equals another identity. The only way you can get that with multiplication is if you multiply them by 1. So fact families will definitely help us on the second one because we're solving for the dividend of this division problem. So that actually is the product of our multiplication problem. So the other two numbers are just factors. You can do 1 times 12, 12 times 1. Either way, your final answer here is going to be 12. That's the product of those two, which means that it has to be the dividend in the division problem. So there we go. We have our two answers there. All right, solving simplify using multiplication properties of 0 and 1. No problem. Again, I hope this becomes instinct sooner than later, but if we see multiplication by 0, no matter what this number is, 23 you can say is big, it's small, you could put a decimal on it, you can make it a fraction, it doesn't matter. Anything multiplied by 0 is going to give us 0. And, just like we went over, anything times 1, that's just the identity property. So 15 is the identity. If you take that and multiply it by 1, you get the identity back, 15. Sometimes I hesitate to circle 0 because it looks like a donut. Not that I hate donuts, I mean I love donuts, but it can be a little confusing in math. All right, simplify using division properties of 0 and 1. Oh, no problem. Especially with these first two, that's pretty good. Because this first one is just 17 divided by 17. And just like we saw, if you divide something by itself, it's just 1. So that's the quotient there. And this next one, that's 18 divided by 1. And hopefully this would really make sense if you put this into long division. 18 divided by 1. Dividing by 1 should be very simple. It pretty much is the identity property of division. And that may sound weird, but yeah, you can divide by 1 and get the same identity back. Just like multiplying by 1 gives us that identity. It's not reversed. It's only when 1 is in the as the divisor. So yeah, we could say, well, how many times does 1 go into 1? It's once. So subtract that 1. You used it up. Drop your 8. How many times does 1 go into 8? It's just 8, right? 8 times 1 is 8. Subtract, you got 0 remaining. So this final quotient here is its identity, 18. Now zeros, though, dividing with and by zeros, this is pretty crucial, because if the 0 is the dividend or the divisor, it makes a big difference. Okay, when it's the dividend, like it is in this first problem here, then your final quotient is just 0. However, yeah, I think I spelt that right. So on this last one, yep, the 0 there, that's now the divisor, which is it's problematic. I suppose if you were looking to actually calculate this, but for us, we're just going to put D and E does not exist, and we'll call that good. All right, 3 times something is 246. Let's look at the fact families and see if this can help us out. Remember, the product of a multiplication problem is also the dividend in the divisor problem. So this is division problems, I should say. So that's 246 divided by either one of the two factors. And the one we know is the 3. So I'm just going to show this is 246 divided by 3. And this should equal the blank from the multiplication problem. And yes, this is nice because it's more direct. So I can set this up with long division because I don't know my 3 times tables up to 246, but maybe you do, and that'd be fine if you did that very quickly. But I'm going to show this with long division. So 246 divided by 3. And I'd say, oh, okay, well, the 3, it's not going to go in the 2 in the hundreds place value. 2 is too small. But it will go into the 24. So 3, how many times does it go into 24? It's 8 times. And yes, that's exact, by the way. 8 times 3 is 24. So after we get rid of that, we don't have anything remaining. So I would just drop the 6 here. And yeah, I'm going to get rid of that 0 just so it doesn't confuse us. But I'm looking at the 3 and the 6. How many times is 3 going to 6? This one's not too bad. It's the second multiple of 3. So 2 times 3 is 6. When I subtract this out, I get 0 remaining. And my final quotient here is 82, which means that back here in the original problem, I can fill in the blank with 82. So we'll do the same thing on this next one. Now this is again, starting as a multiplication problem, but I'm going to change it in using a fact family into its division problem. And yes, the product is always the dividend. So that's 28 divided by either one of the two factors. And yeah, 4 would be the most useful because this is going to give us the blank. So if you need a long division, that's okay. Some of you know that what 28 divided by 4 is. I'll still show the long division on this just because, I don't know, maybe I'm enjoying it more than I should. But 4 will go into 28 7 times. 7 times 4 is 28. Subtract, you get 0 remaining, which is kind of what we want on that. So 28 divided by 4 is 7, which means that's the blank. So I can fill in 7 in the blank there, and that would be the missing number. So that was with multiplication problems. Now we're looking at division problems. No problem. We can still do that by changing these into multiplication using our fact families, right? So on this one, would say our dividend. We don't know that, but we do know that the dividend is the product of a multiplication problem. So the dividend is the unknown there. And we can fill in these two blanks with the other two values. And it doesn't really matter the order. So 35, the divisor, and then 5, the quotient. We can just multiply those two, and that will tell us what our dividend would be. So I'm going to use some stacked multiplication on this because it's so awesome. So I'd say 5 times 5 there is 25. I need to carry that 2 into the tens place value. 5 times 3 is 15. But when I add 2 there, that's going to make 17. So our final product is 175, and that product is also the dividend, which is the blank, or missing number in the original problem. That's what we wanted. This next problem, though, remember and almost by instinct, I find that we want to change this into a multiplication problem because generally it works out that way, right? I'd say, well, there's my dividend, which is the answer to the multiplication problem. You'd have the blank and then you'd have 7, but either way that you write this, whether you put the 7 here or and the blank here or the way that we have it written, it doesn't matter. It doesn't really help us unless you have your 7 multiplication tables all the way up to 112. So now this isn't going to help us, but the other division problem will, hopefully. So I can take the 112 dividend and divide it by what is this quotient over here, the 7. And this would, I can switch that. The quotient with this divisor, I can switch those two out. And yeah, this creates a more direct division problem, which we can perform. So this is 112 divided by 7. And whatever we get from this quotient would go into that blank. So 7 won't go into 1, but it will go into 11 once. 7 times 7 is 7. So we used up 7 of those 11. So subtracting those out would give us 4. Let's drop the 2 to make that 42. And yeah, 7 goes into 42 evenly, actually. It's the 6th multiple of 7. 7 times 6 is 42. So this shows a remainder of 0 there, which is okay. And so this would have been 16, which means this one was 16. Not that we really needed that second fact in the fact family. We really wanted this one in the original to fill in that blank. The missing number is 16. All right, a little bit of sequential stuff. I think we did see a little bit of this, just a tiny bit in one of the sections. Maybe it was a couple of them. Let's go over this just because we're seeing it, though. Yeah, in my head, I was looking at addition on this one, which I think it should work, by the way. Like this one, I'd say, look, from 5 to 15, you would have added 10 right there, right? And then from 15 to 45, you would have added 30. So in my mind, just using addition, that means that we should add 50 to the next one. But I don't think that works. I don't think it works. Maybe two numbers just really isn't enough to show a pattern with those, especially with a changing pattern like this. So I'm going to ignore the addition part on this, okay? And yes, this is part of the multiplication unit and division. So if I see increasing numbers like this in this unit, I should be thinking, well, what? I'm going to multiply the 5 by something to get 15, and then multiply it by something to get 45, and hopefully it's the same thing. If it is, then that shows the pattern. But where the second example shows decreasing values, I should know that I should be using division. We'll get to that one. So 5 to 15, right? I'd say 5 times what is 15? Okay, and this kind of creates a little. I like to show this on the bottom with these little arrows, right? Like what would I multiply 5 to get 15? That's 3, right? And we should have our multiplication tables up to that, from 5 up to 15, hopefully by now. So 5 times 3 is 15. Now, if the pattern holds, that means that I should take the 15, and if I multiplied it by 3, I should get 45. But let's just double check. Okay, and yeah, you could use a fact family to change this one into a division problem. I'm not going to do that just because if we see multiplied by 3 here, then I should expect it to happen again because this should be forming a pattern. So yeah, what do we get when we multiply 15 by 3? 3 times 5 is 15. Carry the 1. 3 times 1 is 3, plus the 1 we carried over makes 45. It does. So 15 times 45, I'm sorry, 15 times 3 is 45. Which means that if I multiply 45 by 3, I should get this last number. So let's go ahead and do that. It's the 45. I'll use the red one because that's the one we got. Multiply this by 3. Well, 3 times 5 is 15. Carry the 1. 3 times 4 there is 12, but add the 1 that we carried over. Going to make that 13. So our final product here is 135, and that would be the 4th term in this set of numbers. So on this one, yeah, with the decreasing values, I should expect division, right? And you could say, well, like 24, it'd be like saying you're going to subtract 12 from 24. So 12, if I subtracted 6 from 12, I'd get 6. And for me, I would say, well, look, see how that's being cut in half right there, which means that I would take away half of 6, then this 6 right here. And so that would be my next value. And I believe it is. But I want to confirm it. Let's see if using division will help us on this, okay? So I'd say, look, you got the 24. We're going to make it into 12, right? So that's 24 divided by what is 12? Well, I got to put the right numbers on there. 24 divided by what is 12? That's what I meant. Well, 24 divided by 2 is that 12, right? So you'd say, well, 24, you could have just divided it by 2, not with a addition sign, but division. There we go. Divide that by 2. Now, again, I would expect that if we took 12 and divided it by 2, we would get 6. And sure enough, 12 divided by 2 actually is 6. So when you take 6 here and then wanted to find the missing value, take 6. All you're going to do is divide it by 2. And 6 divided by 2 is 3, just like we got in green. So this pattern held up. I think it was a little bit more noticeable, even if you use the subtraction. But the division confirms that it actually is the 3 there. Yeah, I wrote that 4 there. I don't know what the heck happened on that. That's a 5. Up here, that's should have been 135. That's better. I don't know why I don't know why I wrote the 4 there. All right, finding missing numbers like this. So on this one, I would be looking at kind of how the numbers are related left and right on this. And in the future, you'll see relationships like this. They're proportional relationships. Not that that really matters right now, but I'd say look at 6 and 12 right there. I would say from 6 to 12 because going up for me is easier. And again, we are dealing with multiplication and division on this, so I'd say, well, look, 6 times 2 is 12, right? Which means that 9 times 2 is 18 as well. So you see this pattern of multiplication by 2 on the left to get that number on the right. So if I just took 23 and multiplied it by 2, I should get this blank. And yeah, 23 times 2, let's go and show the multiplication here. 3 times 2 is 6, nothing to carry, but 2 times 2 is 4, so that's 46. Now the problem with this last box is that it's backwards, right? I'm going from 58 backwards. So where we were multiplying by 2, on this one I'm going to divide by 2. So 58 now divided by 2. 2 goes into 5 2 times. 2 times 2 is 4. Subtract that out. That leaves us with 110 remaining. Let's go and drop the 8 and make that 18. 2 will go into 18 9 times. 2 times 19 is 18, so that shows us that we have nothing remaining there, which is good. We kind of expected it. So yeah, the answer for that box is 29. Yeah, this one's similar to that last table, right? You'd say, since we are dealing with multiplication and division, you can see that 3 times 10 is 30. So the pattern holds because 8 times 10 is 80. So I take 13 times 10 to find this blank. So I'm just tacking a 0 onto the end of that 13, which is fine. And again, going backwards, it'd be like taking 570 and dividing it by 10, which really just cancels out that 0 to make that 57. Translate each using numbers, then answer it. No problem. So we do want the translation on these. Excuse me. So let's go ahead and find the translation first. First, we have this, what is the product of 12 and 6? 12 and 6. Well, product is multiplication, right? And what were the two numbers they gave us? It was 12 and 6. So I just need to multiply 12 and 6. Okay, so this would be the translation, which was pretty direct in this case. And yeah, 12 times 6, let's go and do, again, we kind of want you to have this memorized, but we're still getting used to it. So I'm showing the stacked multiplication on this one. So I'd say, look, 6 times 2 is 12, carry the 1, and then 6 times 1 is 6, but add the 1 that we carried to make that 72. So this would be the actual product right there, whereas the 12 times 6 would have been the translation. So this next problem, it's still using 12 and 6. That's nice of them. But in this case, it's a quotient, which means we're looking at division. And what are we dividing? Well, it's 12 and 6 again. And it's in that order. So 12 is our dividend. 6 is our divisor. So 12 divided by 6. When we do divide that, we would get 2, right? Yeah, we can show the long division. 6 goes into 12 exactly 2 times. 2 times 6 is 12. We see we got nothing remaining on that, so 2 would be our quotient. And 12 divided by 6 would be our translation. And this first one gives us the product of 5 and what number is 325. Okay, well, that's a product, so that's multiplication. So it'd be 5 times something equals 325. And this is a good translation. Again, on the homework assignment for this one, if it wanted the translation, maybe you'd put a question mark in this, but we're good on the review for this one. So since it's a multiplication problem, this means that we can use a fact family to solve this one. And yeah, the product here is going to be the dividend, so that'd be 325. And we can just divide this, right? That's part of our fact family, and whatever we get on this one is going to be the answer. But either one of the factors will work as the divisor. So I choose the 5 because this gives us a more direct translation, right? Now it's 325 divided by 5. And we can perform this division with long division. So that's 325 divided by 5. So 5 doesn't go into 3, but it will go into 32 6 times. 6 times 5 is 30. Subtract that out. You got the 2. Drop your 5 there. 5 will go into 25 5 times. 5 times 5 is 25. So yeah, we show 0 remaining. Do those backwards. A remainder of 0, which means that the number would have been 65 right there. So what about the quotient? Well, the quotient of 315 and what number is 9? So quotient is division problem. You know, we're looking at 315 and some number, but it's 9. The quotient is. Yeah, we're going to need a multiplication problem to solve this one. So I'm going to make the dividend the product of a multiplication problem. So that'd be 315. Nope. Maybe that's not going to work. Again, I guess I've said that, right? The divisor and the quotient would be the two factors. But that doesn't really help us. It's not a direct translation. So let me change that and rewrite this, but with a new division. So the dividend stays the same as 315, but now it equals. I can just switch the quotient and the divisor to make this not equals, but divided by 9 equals the blank. All right, well, that's much better because I know that I can actually divide 315 and 9. I don't know if there will be a remainder. Let's find out. So 315 divided by 9. 9 goes into 31. That'd be 3 times. 3 times 9 is 27. So we used up 27 of the 31, which means there's 4 remaining. Drop the 5. 9 will go into 45 exactly 5 times. 5 times 9 is 45. So that shows a remainder of 0 there as well, which means that the number that was missing in this one is 35. All right, Tori bought 7 cases of tomato soup. Each case combined 12 cans of soup. How many cans of soup did he buy? So, well, 7 cases, right? And again, if pictures help, like if this was a case, you'd have 7 cans in it. I don't know how they're stacked, but, and you could do this. I said 7, I meant 12. 9, 10, 11, 12. You could keep doing this until you figured out how many cans there were total. But really what we want on this one is multiplication because it's 7 groups of the 12. So that's 7 times 12, which we can use stack multiplication. Again, if you're still working on your multiplication tables up to 12, that's good. 7 times 2 is 14, carry the 1. 1 times 7 is 7, but we need to add that 1 onto that 7, so that's going to make that 84. Now again, just with problems like this, if you're doing it by hand, it's saying how many cans of soup. The answer is not just 84. You need to label that And just putting cans is okay. You can put cans of soup if you'd like, but make sure there's a label on that. I mean, it should be appropriate. It's not 84 tomatoes, by the way. It's not 84 cases. It's 84 cans. And again, if you want to be more specific on that, make that cans of soup. That's fine. Lecture hall contains 85 students. I think there's supposed to be a hyphenation in that. If the teacher puts the students in groups of 5 students, each group, how many groups are there in that class? Oh, okay. So we got 85 students, and we're going to divide it up into 5. This will tell us how many groups there are. And we know it's division because it's asking how many groups exist with each group having 5 students. Now, again, you could make a chart or a diagram for this one, but I think the division will suffice, which means that I'm going to use some long division on this. 85 divided by 5, right? Dividend divided by divisor. And 5 will go into 8 once. 1 times 5 is 5, so subtract that out. We get 3 remaining. And if I drop this 5, then it becomes 35. And 5 will go into 35 exactly 7 times. 7 times 5 is 35. Proves that it goes into it evenly. So we have a remainder of 0. And so we get a final answer here of 17. But again, it's not just that it's 17. We need a label on this one. It was asking how many groups. Well, 17 was our answer, so it would be 17 groups. Find the area of this shape. That's just a rectangle. So we should be able to take the length and the width and just multiply those out. So that's 11 times the 7 there. And 11 times 7 is 77. But again, don't forget to label this one, right? It's not just that it's in feet, but it's actually in square feet. So maybe I didn't need to erase that because there's 2 different ways to write it. But I'm going to put square feet like this. That's a cube, by the way. But yeah, you could have written it as 77 feet squared if you wanted to. And again, it doesn't change the number, the value. It just changes the way that you write the label, and both work. All right, below is the drawing of a room. Find the amount of carpet needed to cover the floor. Oh, so this is kind of like the problem we covered at the beginning of class. And yeah, we are looking for area. So what we're going to do is we're going to split this up into 2 separate rectangles. And I'm just going to do it pretty much the same way we did that one in the beginning. So what I mean is I'm going to cut this horizontally. Okay, and yes, you could cut it vertically as well. So if you wanted to cut it right there, you'd be fine to do that. You'll get the same exact area. The 2 areas that we're going to find may be different, but when we combine the 2, they'll be the same. So let's see, what have we got? Well, gotta redraw it for it to work, I think. Let's go ahead and, there we go. So I have this red rectangle. I'll make this big enough for us to see. And this red rectangle, I know one of the dimensions at least. This is 20 feet right here. I also do not know the height of this or the width of it. Okay, so I'm gonna have to figure that out. But let's look at the other rectangle first, which is this one. And yeah, we do know the dimensions of this one. Here, this purple one. So let's see if I can break this off. There we go. So it's this one right here. And yes, I'm sure a lot of you could make that a better drawing than I did, but hopefully this will work. So that's a 8 foot by 11 foot, right? And yeah, I'm not using that 18 feet because it was the full length of that side on the left. But I still need this length on the red side. So I'm gonna use the 18 feet on the left to figure out that length. And so yeah, this whole part is 18, but this part of the this part of the purple rectangle is 11 feet, right? So if I want to figure out that red side, I need to take the full length, which is 18, and subtract that part of it, which is 11 feet in purple. That's going to tell me how long that red section is. So 8 minus 1 is 7, 1 minus 1 is 0. So it looks like this length right here is 7 feet. So I know it's a 20-foot by 7-foot rectangle now, and I'm ready to find the area of both, because the area of the purple one is going to be 8 times 11, which is 88 square feet. I'm not going to put the label on it yet because I know this isn't my final answer, although you could. And the area of the red one is a 7 by 20 foot rectangle. 7 times 2 is 14, and then I'm just going to tack on that 0 at the end. All I really need to do now, in order to find the area of what would have been starting as that orange one, is just add those two areas together. So 8 plus 0 is 8, 8 plus 4 is 12, but carry the 1. 1 plus 1 is 2. So we get 228, and I'm going to put this as square feet as our final answer on this one. And again, just going back, if you wanted to split this up, I can't do it for the sake of time, but if you wanted to make it this rectangle and then figure out your area of this rectangle to subtract from it, you could have done that. But your answer still is going to be the same, 228 square feet. All right, this one's kind of new, I guess. The area of the shape is 24 square feet, and yes, the shape is a rectangle. So we need to find that missing side length, and well, what the heck, I'll put it here on the right. It doesn't matter if you put it on the left, though. We do know the 6 feet, and we do know the area. So 24, that's the area of the shape. It should equal the length. I'm going to say that's a 6 foot length, and we're going to multiply this by, well, we don't know. I mean, we're going to find out, but we don't know right now. So you could say, well, yeah, and if you know your multiplication tables well enough, you'd say, I know what this number is right now, but I'm going to change this into its division fact family. So that means that the 24, which is the product, is also the dividend. And I can change this to division. And so either one of those factors can be the divisor, so I choose the 6, which is going to make this a more direct calculation. This will equal the other factor, which we don't know. But once we know that, we'll know the answer to this length right there. So I really have 24 divided by 6. So we'll show it 24 divided by 6. 6 goes into 24 evenly 4 times. 4 times 6 is 24. Subtracting shows a remainder of 0. That's good, because then it shows that our answer is 4 for both cases, and so this length here is 4 feet. And yeah, don't forget to label that one as well. Don't just write 4 in there, especially if you're doing it by hand. Make sure that it's in feet. And so even when you guys are taking the quiz, just make sure if it asks for you to put the label in there, that you put it in. Sometimes it may just be a drop-down menu, which makes that kind of convenient. You know, it gives you some options to choose from, but you should always be looking to label these if you see word problems. Even like this, right? This would be considered a word problem.